In this video, we're going to learn how to perform stoichiometric calculations in which there's a limiting reagent. So if we're considering the synthesis of water, 2H2 plus O2 yields 2H2O, and we have 4 hydrogen molecules and 3 oxygen molecules that we mix together and force to react, if we're asked the question of how many water molecules we can form, we might not have it be that the hydrogen and the oxygen run out at exactly the same time. Maybe there is one that runs out first, and then there's some leftovers of the other one left behind. So let's think of this. If we need 2 H2s, then I can take an H2 and another H2 and get them to react with one O2 here, and we'll get 2 H2Os, which I'll just write as H2O and H2O. And then we also have 2 more H2s reacting with 1 more O2. So we'll have H2O and more H2O. But notice we're getting, from our 4 moles of hydrogen, we're getting 4 moles of water. But from our 3 moles of oxygen, we can't react that last mole of oxygen with any more hydrogen if there's no hydrogen left. So there's still an O2 that's just hanging out over here that hasn't reacted. In this case, the limiting reagent is the one that runs out first. That's the hydrogen. And the excess reagent is the one that there's extra of, and that's the oxygen. So that's all well and good, but what if we have a calculation to do, we don't have the particle diagram up, what if we have masses? How can we figure this out? Well, let's say we have the 4.04 grams of hydrogen, which I'm going to put here, and we have 16.0 grams of oxygen. What we can do is, ultimately we're going to be going to moles, and then to moles of water, and then grams of water, if we're trying to find the mass of water that we can form. But we need to know which we need to come from. Do we go to moles of oxygen and then to moles of water? Or do we go from moles of hydrogen to moles of water? What is our calculation going to be based upon? Well, let's figure this out. Let's go to moles. And if we do our calculation of moles, we have 4.04 grams of H2 times 1 mole over every 2.02 grams. Pardon me for not doing the calculation out, but it's 2 times 1.01. We get 2 exactly, 2.00 moles of H2. And for oxygen, well, we have 16.0 grams of O2 times 1 mole over every 32.00 grams of oxygen, and that leaves us with precisely 0.500 moles of O2. So we have 0.500 moles and 2.00 moles. And what we can do here is we can say that we have this many moles of each starting material. So the next thing that we're going to say is if used. So if used means that how much are we going to use? Are we going to say that the oxygen is going down to 0, or are we going to say, and be the limiting reagent, or are we going to say that the hydrogen is going to be the limiting reagent? In this case, you can guess, but typically you can make a pretty educated guess. I know that these react in a 2-to-1, and in this calculation, it's pretty easy to see. I've got half a mole of oxygen. I need twice as much hydrogen, so I only need 1 mole of hydrogen to react with it. So quite clearly, we're going to have the oxygen go down to 0. It's all going to be used up. So I'm going to say 0.500 moles of oxygen is used, and that brings us to 0 as our leftover. This means I'm making this assumption, right? I'm making the assumption that we use up all of the O2, meaning that we go down to 0. And now what I can do is I can calculate the amount of hydrogen required to react with the 0.5 moles of oxygen. And I can do that with a simple stoichiometric calculation. What I can do is say, okay, we've got 0.500 moles of O2. And I'm actually going to do this, I'm going to go up here because I'm going to end up splitting this into two things later on. So I'm going to say this is times, what is it? Sorry, it's 2 moles of H2 required to react with every 1 mole of O2. And this gives us 1.00 moles of O2 that are required for this to occur. So the used amount is going to be 1.00 moles, which means if we subtract 2 minus 1 gives us 1.00 moles of hydrogen that are left over. And the fact that this is a positive value indicates that my assumption here in starting with the O2 as the limiting reagent, that was correct. If I had started with hydrogen as the limiting reagent and I brought that down to 0, then my leftover oxygen would be a negative amount, and that would indicate to me, whoops, I made a mistake. What's nice is that if you do make the correct assumption, if you're ever asked a question where it says, hey, what's the amount, like fine, what's the product that you get, but also what is the amount of leftover excess reagent? Well, it's right here and it's fairly easy to take. You could just multiply this by the molar mass of oxygen and you'd find out that there are, what, 32, oh, sorry, this is supposed to be hydrogen, excuse me. There are 2.02 grams of hydrogen left over. Excuse me, that should have read hydrogen. So H2, there we go. So finally, answering the question here, what mass of H2O can we form? Well, we have half a mole of oxygen, and what we can do is simply do the typical stoichiometric calculation. We're starting at our 0.5 moles of O2, and we need to go to moles of H2O. So I'll put this here, and then we'll go to grams of H2O. The mole to mole ratio is a 1 to 2. I'm not even going to try the calculation for water. It's 2 times 1.01 plus 16 would be 18.02 grams of water for every mole. So what I can do here is take our, I'll say 2 moles of H2O for every 1 mole of O2. And then I'll multiply by 18.02 grams of H2O for every 1 mole. And what I end up with is 0.5 times 2 is 1, divided by 1 is 1, times 18.02 over 1 is 18.02 grams. But actually, I've got to round it to 3 sig figs, so we get 18.0 grams of H2O that is produced. And there's our answer. So 2 different ways to do this. This is one way that will help you later on if you do equilibrium problems. There is another way in another video that we have that also would get you to the same conclusions. So it's up to you which you use. Anyway, thanks for watching this video. Let me know if you have any feedback or questions in the comments section below. Thank you.